Okay, grade 12s, I've just had you but I didn't press video. I didn't press the video button, so I'm going to tape it again. So I'm going to try and remember what I said today. So basically we are finishing off mutations, and if you remember yesterday we looked at polyploidy and chromosomal mutations like Down syndrome and Turner's and Klinefelter syndrome. So let's just look at a few more. All right, so over here, okay, so this is now tying up with the genetics that we've been doing. So I'm going to be walking up and down. Okay, so this is normal autosomal recessive disorders like albinism and cystic fibrosis. If you remember, in order for parents to have an albino child, they both need to be heterozygous, and it's the same with cystic fibrosis. And cystic fibrosis is also two carriers have a 25% chance of having a cystic fibrosis child. Okay, so that's the normal one. That's what we are used to, autosomal recessive. Okay? Then if we look here, albinism, so it's when there's, because of a mutation in that gene, they either produce very little pigments or no pigments, and it's because they don't have an enzyme that helps them to produce melanin, which gives skin color. Okay, it's found not only in humans, it's found in vertebrates as well, and like I've shown you over there, there's the genotype, and they can have lots of things wrong with their eyes, like photophobia, light, scared, that they get bothered by very bright lights, and astigmatism. And astigmatism is where the cornea, the front part of your eye, instead of it being nice and round like a soccer ball, in all directions, I've actually got astigmatism where it's more like rugby ball shape. So the cornea is longer in one direction than the other. So when I drive at night, the light rays, when they pass through, I see, instead of seeing street lamps as a solid light, I see it with rays. And that's simply because my cornea is not round in all directions like a soccer ball, it's more like a rugby ball. So they can have that as well. Okay, so it could be in crocodiles, gorillas, porpoises. I've even seen a peacock thick photo of a peacock who has albinism, lots of different organisms, okay? And there are lots of famous models nowadays who have albinism, okay? And because they don't have pigments, so just like I've got a brown skin, it prevents too much UV light from passing into my skin, which could damage DNA and cause cancer, cause DNA to mutate. So if they don't have any melanin, then they are very prone to skin cancer because there's no filtering of UV light. Right? And also the eyes are very susceptible to light. Okay? So then cystic fibrosis. So remember, it's also a autosomal recessive condition. It's got this fancy name called mucoviscoidosis. You don't need to know that. The mucus in the trachea and bronchi is not viscous. It's very sticky. And it's found, this particularly mutated gene, there's quite a few genes that cause cystic fibrosis, and it's called the CFTR gene, and it's found at that locus on chromosome 7, and you don't need to know that. But remember, the banding pattern here is the staining of the chromosomes. It does not mean that that's a gene. I mean, there's hundreds or thousands of genes on this chromosome, and at that region is where the DNA is mutated. Right? So there's about 500 different types of mutations that cause cystic fibrosis. It produces a very abnormal sticky mucus in the bronchi and the trachea. Their pancreases also don't, they can't secrete enzymes in mucus, and also they make a very salty sweat. So my second child, when she was born, they were worried. The one doctor said, "Oh, I think she might have cystic fibrosis because she had a very weird form of pneumonia," or they thought. And they gave her antibiotics, which were actually quite bad for her. But then what they did to check for cystic fibrosis is it's like a hot disc. I remember they taped a hot disc, like bandaged it on her, a metal disc, onto her little palm, wrist at least, and then we had to wait a couple of hours at the hospital, and then when they remove that, if there's lots of very salty sweat, they test it at the lab, and then they would know that the child has cystic fibrosis. They produce lots of salty sweat because water is kept inside, they don't make watery sweat. Okay, so it's also autosomal recessive, so little And, okay, so what, can cause infertility in some people. It does affect the pancreas, which produces enzymes, and the glands in the intestine, which produce mucus to help the food to move along, and even the bile ducts, where the bile passes out of the gallbladder, and the glands of the bronchi, well, trachea I think as well, yes. So the glands in the respiratory tubes, instead of them producing a watery mucus, they produce a very sticky mucus, and that sticky mucus, remember, they're little cilia, so normally mucus is passed up and out, but because they've got this very sticky mucus, the bacteria in that, if there are bacteria, they stay in the respiratory tract, and that can cause lots of infections. So they've got to have things like physio and medication and all sorts of things. All right, and there again, the sweat glands, they produce very salty sweat because water is kept in the body. All right, so the treatment, okay, so chest therapy, where they have to, bang them on the back to try and draw that mucus out. They get a modified diet. I mean, even me with my sinus problems, I don't drink a lot of milk because the minute I do that, then I start making lots of sticky mucus like I have now. They have to take pancreatic enzymes because they don't secrete enough of them, and they use very specific antibiotics to try and control those lung infections. And what we're going to do next week is something called gene therapy. And it's a type of genetic engineering where they actually modify, for example, bacteria, or they even use viruses which have been disenabled, and they carry the correct gene into the respiratory tubes to try and correct this, well, not to correct it, to try and ease the symptom, because the gene is there, okay, so they try and get the cells to take up the gene, and I'll tell you next week, it's only short lasting though, it has to be done a number of times, and it's not always very successful. So that's gene therapy. Okay, so basically what happens, it's actually, this is the part of the actual gene that produces this protein that helps make normal mucus, but there's a codon, a triplet codon, number 508 codon is missing, so therefore that amino acid is missing from that protein, and therefore it interferes with the production of mucus. So in a normal person, you don't need to know this. This is just to make you realize how one codon can affect somebody. So in a normal person, if this is the inside of the cell and that's the outside, we're thinking of the cells lining the respiratory tubes to produce mucus. So in a normal person, this protein helps chloride ions to be pushed out. So that chloride ions are salt. What follows salt? Water. All right. So we would make a normal watery mucus, and the cilia would move that mucus out with dust and bacteria and things, and then, to try and prevent us from getting ill. But someone with cystic fibrosis, this protein doesn't work properly, so these chloride ions are not pumped out. So what happens? Water follows salt. So instead of them secreting a watery mucus, a more watery mucus, the water goes inside the cells. And now you've got no mucus in the trachea or the bronchial tubes, or it's very, very sticky, okay? Less water is produced or passed out of the cell, and therefore they get infections because bacteria that end up staying. It's a nice environment for them. All right, so, okay. So that was autosomal recessive disorders, and then if you remember autosomal dominant disorders like Huntington's disease, or we can call it Huntington's chorea, or HD, or even polydactyly. So remember there now, you only need one copy of the dominant gene to have this disease, which usually only the symptoms appear in later life. So it's quite uncommon, but remember we said it's common in a particular family in Ecuador and in some of the Afrikaans community in our country. It is found on chromosome 4 at that position, which you do not need to know. All right, so it's an autosomal dominant gene, okay, which we know, that's the genotype. And then they have those, it's progressive cell, nerve cell damage. Involuntary movements, they can't walk, they can't coordinate. That the brother was the one, he helped shave his brother who had Huntington's chorea, for example. They get dementia, memory loss, etc. And that's just because of that. Remember, there's a repeat of, I think it's GAC, 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 GAC. So therefore the protein that works around the nerve cells doesn't work properly, and there's an accumulation instead of normal nerve cells. All right, so let's go over here. Okay, so treatment. So they are trying, well, this is a little bit old, but trials of gene therapy look promising. There are some drugs that interfere with the Huntington protein that they can try and lead a normal life, and then obviously genetic counseling. So if a man knows that he's got Huntington's because it's in his family, or if he's not sure if he has Huntington's because maybe one of his parents had it, then they can go for genetic testing. So if one of the couple have got Huntington's, then they need to know the odds of having a child with Huntington's. So that's what genetic counseling is all about. So first of all, they might be genetically tested to see if he actually does have the Huntington gene, because remember, the symptoms only appear later on in life. So using our basic genetics, okay, monohybrid crosses, right? So if that's dad and there's mom, dad, and then they say, okay, you do have Huntington's, so now they want to know the chance of having a child with Huntington's. So capital H, small, 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 big, small, small. So there is a 50% chance of their child having Huntington's, and then that's where genetic counseling comes into play. So they would tell the couple the chance of having, and then give them options. So if they aren't already pregnant, then maybe they can adopt, or maybe they can have embryo screening, IVF, where eggs are fertilized outside the body, the little embryos grow, they can genetically test the embryos and only put the embryos in that do not have Huntington's, all right? Or they could be given advice about having an abortion, but I mean that's up to every couple, all right? And it's the same with other diseases as well, like cystic fibrosis. They can have genetic counseling, or Down syndrome, where they can find out what kind of help they can get before the baby's born, find out information after the baby's born, how they can get help, different organizations that will help them, assist them in schooling and equipment, for example, for a child with cystic fibrosis, and where they can go for physiotherapy. And so it's like a support group. And those kind of support groups are all over the world, including our country. Okay, so genetic counseling is all about testing for the gene, and then giving the couple telling them what the risk is of having a child with cystic fibrosis, Down syndrome.